Hello. Happy Sunday, everybody. It's been a while, actually, because I didn't stream on Thursday, right? Because if you pay attention, I've moved. Although, as you can see, I haven't really unpacked too much. But I have set up my computer. Now, some goods and bads. I think my internet is kind of shitty, and it might disconnect me. So the stream may go well, or it may go bad. Hello, Serpent. But, as promised, I'm going to continue with the 2021 Math IB papers. So today, we're going to go over... Which one am I going over? Time Zone 1, Paper 2. Oh wait, this is HL. I don't want to do HL today. I want Time Zone 1, SL. So hold on, let me go and find that real quick. So this dude said, he asked for my email last stream, and he was like, I'm gonna ask my teacher to send me the exams to send you for a trade. And so I did trade, but he hasn't given me his part of the bargain yet. So I don't know how I feel about this. Did I just get like scammed? I feel like I might have been scammed. And I really hope that I didn't. Okay, here we go. So Time Zone 1, Paper 2. Still possibly waiting on someone to provide me with Time Zone 2s. And I'm gonna try to finish this as fast as I can because, like I said, I'm pretty busy with unpacking stuff. So I'm gonna call it a stream as soon as I finish this. Now this paper has mostly good reviews. I think a lot of people said that this was easier than Paper 1. However, there have been a handful of people that have said that they found it harder than Paper 1. But let's see. This looks pretty easy right here. Let's find this integral. So that's gonna be what? 3x squared plus 7x plus c. And, you know, keep an eye out for the plus c. Otherwise you'll lose some marks. And then, given that the derivative of a function is 6x plus 7, okay, find the value of the function at the function at the value of 1.2 is 7.32, then we need to find the actual function itself. Okay, easy enough to do. We essentially already found the function, we just need to find the constant. And to do that, they told us this piece of information. If we just plug in 1.2 for x, it will equal 7.32, then we can solve for c. So basically 3 times 1.2 squared plus 7 times 1.2 is plus c is equal to 7.32. My tablet is being calibrated kind of weird. I don't know if you guys can tell, but I'm writing kind of like wide. Aha, okay. There we go. Okay, so let's see. So 3 times 1.2 squared plus 7 times 1.2. This is gonna be 12.72. Therefore, C is gonna be the difference between 12.72 and 7.32, but negative, so negative 5.4. So your actual function itself 3x squared plus 7x minus 5.4. Here you go. First question. Easy peasy, 6 marks. Hello, Vincent. How are you? Oh, so I saw this question. It was so weird. You're in big trouble? Why are you in big trouble? Did you not do something? You've done literally nothing? That's okay. I'm sure it'll be fine in the long run. Okay, so we have some data collected on an experiment, and then it's now plotted on the scatter graph. And then you can have a linear regression of y on x, and we need to find the value of a and b. So this part's not the weird part, because this is very standard. So we are going to go to my list, clear out the old stuff. We had an English project due on Friday and you haven't touched it. Had, as in past tense, as in it's overdue. Crazy. So let's input these values. Yeesh. And what, did you get an extension? No? What? Then isn't it over? Shouldn't you just move on and just collect the 0 or whatever? Like what's the protocol? Do you still need to do it? Do you lose marks? Anyways, okay. Just hand it in late? Oh, then whatever. And then just hand it in a week late. Next Friday. Give yourself some more time. Yeah. It's always better to ask for forgiveness than permission. Okay, so where am I? So here's my A, here's my B, to 3 significant figures. So A is 0.433, B is the other number, 4.5. Probably not true in this case. Nah, you'll be fine. It's already late, so why not just, you know, double down. Give yourself an extra week, hand it in on Friday. Next Friday. What's the big deal? Okay, so then now we have our coefficients. Therefore, we can use this model to predict the value of y when x is 18, so that's fine. The first 2 questions are fairly straightforward. So we do 0.433 times 18, and then plus 4.5. So it should be 12.3. Okay, that's fine. Then we find the average x and then the average y, the mean. So because they're already in my lists, I can go to 2 variable statistics and then just say my x list is list number 1, y list is list number 2, press calculate. So my average x is 15, my average y is 11, and then now, this is the interesting part. I'm not going to copy it, but the last question says to draw the line of best fit for this scatter diagram. And that's extremely abnormal. I've honestly never seen them ask you to draw a line of best fit before. It's not hard, but it's just so odd that they would do it. It's worth 2 marks as well. Okay, so there's 2 requirements for a line of best fit. The first one is the one that everyone knows, which is you try to make the line not deviate from too many points. Like it needs to be as close to all the points as possible. Obviously some will be still farther away than others, but we want to minimize all the distances. And then the second one is the line of best fit needs to go through the averages of the x's and the y's. So before you do draw your line of best fit, you should make sure that you go through 15 and 11, the coordinate 15, 11, which would be right here. And then I'm not going to draw a line of best fit that I would probably, well, I'm not going to draw one that I feel like would be correct, but I'll try my best. Because this is why I thought they wouldn't ask these types of questions. The line of best fit is a little subjective. So as long as you go through this point and you're reasonably close, I think they'll give you the marks. It's just such an odd question. It's not hard, but it's just very odd. Anyways, you have lots of other things to do. You will always have lots of other things to do. Did you finish my work? Okay. Yeah, see, math is fine, and this week will also be fine. Super easy. If you understood yesterday's, you'll understand this Wednesday's. No? You didn't do the math? What did you do for that hour then? But it will be fast, so I'm not worried. Wow, okay. What is this? A company produces bags of sugar, okay, and its masses in grams can be modeled by a normal distribution. Mean of 1,000, standard deviation of 3.5, sure. A bag of sugar is rejected for sale if its mass is less than 995 grams. Find the probability that a bag selected at random is rejected. So we want to find the probability, and then let's say X is the bag. We need to find the probability that its mass is less than 995. So this is easy enough to do, because you just go to your distributions, you go to normal CDF, you input a lower bound and an upper bound. For the lower bound, you know, just put something reasonable. I guess 0 is pretty reasonable. The upper bound was 995. Your mean is 1,000. Your standard deviation is 3.5. Punch this into a calculator, and then there you go. She was busy arguing with you? Hi, Anzoma. How are you? So the probability of the bag being rejected is 0.0766. Okay, now estimate Snake Star. Yeah, remember this paper, number 2? Estimate the number of bags. Oh, this is the one that you have more trouble with, right? Estimate the number of bags that will be rejected from a random sample. Well, we know the probability of rejecting one bag, so the expected number to be rejected from 100 is 100 times the probability of a single bag being rejected. So we're just going to multiply this by 100, and then you have 7.66. I mean, I didn't need to put that in a calculator, but sure. How do you mess up this question? Now, estimate the number of bags. Do they want you to round this? I honestly have no idea. I would probably just leave it like this. It's only 1 mark, so I think you don't need to worry about it. Okay, given that a bag is not rejected, find the probability that it has a mass more than 1,005 grams. So they specifically tell you that it's been given, so this is a conditional probability. So we want to find the probability that you're more than 1,005 given that you are not rejected. In other words, you are more than 995. So again, that's not rejected. Oh, you did well on this one. Oh, on this specific question? Anyways, so we just follow a conditional probability formula. So down below is the probability of not being rejected. And then up above is the intersection of these two. So x being greater than 995, and then the intersection with x being greater than 1005. Okay, let's talk about the denominator first. So in the denominator, we already know the probability of being rejected. So the probability of not being rejected is the complement. So down below we'll have 1 minus 0.0766. And then you need to figure out what this intersection is. But this is kind of a funny intersection. If you are greater than 995 and you are also greater than 1005, the intersection of these two things is just this one. So this just reduces to this probability. Because again, look at this picture. So here's like 995. And then here's like 1005, let's say. And you can clearly see that the intersection of the two areas is just the orange area, because the orange area is inside of the blue one. So this intersection is just this probability, which we can calculate. So we go back to our distributions, normal CDF. So our lower bound is 1005, and then our upper bound is just something, you know, extremely large. So we can do like 10 to the power of 99. That's pretty big. Paste it, calculate it. Okay, so that's our numerator. And then we are going to divide this by the complement of the rejection. And there you go. That should be our answer. So 829. Okay, not bad. Easy first 3 questions. Oh, look, a Ferris wheel. My class better know how to do this. Oh, I went on the subreddit and some people were like, what the hell was this Ferris wheel question? I don't even know what a Ferris wheel is. It's kind of sad. Because this is like one of the first examples I always teach when I talk about sine waves. Okay. You got a Ferris wheel with a diameter of 110, which means that it has a radius of 55. The lowest point on the wheel is 10 meters, sure, above the ground. And then point P is on the wheel, and then it rotates this way. Now P starts at the bottom, and then it goes upward. And then it does 1 revolution in 20 minutes. So this is the period right here. The period is how long it takes to do 1 revolution. Okay, so we need to model this graph. Easy enough to do. First off, let's draw out what the wave should look like. At its lowest point, it starts at the bottom as 10, and then it rotates upward to a maximum, and then it rotates back down to complete a revolution. And this should take 20 minutes. If the diameter of the wheel is 110, then the maximum height is 120. 10 plus the radius is going to bring you to the center of the wheel. So that would be 65. How did I get the paper? Read my bio. How'd you find me? So my midline is 65. Now, a couple of things. Amplitude of the Ferris wheel is the radius, which is 55. And then, let's see. And then what I'm trying to do is eventually I'm working my way to finding A, B, and C. A is related to the amplitude. It is the number 55. But because we want a cosine graph, and your Ferris wheel starts on the bottom, this is an upside down cosine graph, so we have a vertical reflection, so A is negative 55. Now, C is easy. C is just the midline is what I call it. So it has been vertically displaced by 65 units upward. So this is 65. And then B is 2 pi divided by your period, which is 20. So in other words, it's pi over 10. Yeah, see, I told you guys. This was literally a question from this year. Ferris wheel. Y'all were complaining about Ferris wheels. So your function should be negative 55 cosine pi over 10t plus 65. Easy peasy. Okay, this looks like some calculus. So we got particle moving in a velocity using this function from 0 to 10 seconds. Sure. Here's a graph of the velocity. Okay, find the smallest value for t which the particle is at rest. So when you're at rest, you are not moving. So that means that your velocity is 0. So here are the values where you are at rest. We want the smallest value of t, so we need to find out this one. I really hope you guys didn't put 7, because that's not 7. You have the function here. Just calculate the 0 using your graphing calculator. I mean, it might not be 7. I'm not going to say that it's not for sure 7, because I don't know, but that doesn't look like 7 to me. So x sine x minus 3, and then I need to make sure I'm in radian mode, otherwise this will not work. And then change my window from 0 to 10, and then negative 8 to 10, sure, that works. So there we go, here's the graph. And we need to find this 0. So we go to second, calculate the 0, and then we select a left bound on our cursor. So put my cursor on the left side of the 0, on the right side, and then put a guess. So 6.74. Okay. Find the total distance traveled by the particle. So I've said this in a lot of my videos, but we are going to take the integral of the absolute value of the velocity. Otherwise, you're going to have to split this up into 3 sections. This section where the area is negative, this section where it's positive, and then this third section at the end where it's negative again. And then you need to, make sure that the negatives and positives don't subtract because we're trying to find total distance traveled. But all of that can be mitigated by taking the integral of the absolute value. So we'll just do that. Save ourselves some time. Oops, let's exit this. So this goes from 0 to 10 seconds, I believe. Yeah. And then my function is going to be the absolute value of x sine x minus 30. And my variable of integration is dx. Let it crunch the numbers for a bit. And there you go. Total distance traveled, 37.1. Okay, and then find the acceleration of the particle when t equals 7. So this means we take the derivative of the velocity and then we plug in 7. And this is a calculator function as well. So n deriv, d by dx, our function is x sine x minus 3. And then we want to evaluate this at an x value of 7. So there's my acceleration, 5.93. Not bad. Another easy one. Feeling good. That's like a... If you did the first 5 questions, and what are these? 6-ish marks each? So what are you standing at right now? 30 marks or so? That's basically a 3 or a 4. Not bad. Okay, and this looks like a binomial expansion. Binomial theorem. Okay, consider this expansion. Okay, n plus 1, that's a little new. And then let's see, given the coefficient of x to the power 4 is this, we need to find the value of n. Ah, okay, this is a little different. Normally they give you this exponent and then you want to find the coefficient, but I guess they just want to screw with you. Okay, so we know that the x to the power 4 term can be written from your formula book as this right here. Let me zoom in. So right in the middle, this part is the general term. So it's NCR a n minus r times b to the power r. So our exponent is n plus 1. We don't know what r is for now. And then it's 3 to the power of n plus 1 minus r times x to the power of 2 to the power of r. Okay, now because this is the x to the power of 4 term, then look at the factor of x here. We need it to be x to the power of 4, so this means that we can say that r is going to be 2, because x squared to the power of 2 is going to be x to the power of 4. So now I know that all of these are going to be just 2. And then plus 1 minus 2 is minus 1. And this is 2. Now it says that the coefficient of this is 20,412. So if you look at the factors that contribute to the coefficient, it will be these 2 factors right here. This combinatoric number and this 3 to the power of n minus 1. So this will equal 20,412, and then we can solve for n from there. Okay. So we have 3 to the power of n minus 1. This is equal to 20412. And then what we need to do is we need to write this in terms of its actual numerical definition, which is right here. So this is going to be n plus 1 factorial divided by 2 factorial times, technically it's n plus 1 minus 2 factorial, which as we saw earlier, the plus 1 minus 2 become minus 1. Okay, and then of course you need to remember what factorials mean. So 5 factorial means that you take 5 and then you multiply it by 4 by 3 times 2 and then you stop at 1. So this is what a factorial is. And this will help us simplify, because here, I guess I'll do it in orange. N plus 1 factorial, if you just expand it out, is n plus 1 times the next number decreasing by 1, which is n, times n minus 1 times n minus 2, all the way until you get to 2, well 3, 2, 1, let's say. And then down here at the bottom, 2 factorial is actually just 2, so we don't have to worry about that. And then we have n minus 1 factorial again. Well, not again, but we have n minus 1 factorial, which is n minus 1 times the next number after you subtract 1, which is n minus 2, n minus 3, all the way till 3, 2, 1. Again, this is just the definition of factorial. Now, when you have 2 factorials divided, the smaller one is always going to be cancelled inside the larger one, because as you can see right here, n minus 1 factorial is part of n plus 1 factorial. I want to use red. Actually, that probably won't look good against orange. I guess. Fine, I'll use blue. So all of this stuff will cancel with all of this stuff. So what you're left with in this equation is n plus 1 times n over 2 times 3 to the power of n minus 1 is equal to 20 whatever this was, 412. And then we solve for n. Easy enough. Put it in the equation solver, you can graph it, anything you want. So I like graphing things. I hate using the equation solver. So I'm gonna have, what is this? X plus 1 times x divided by 2 times 3 to the power of x minus 1. Okay, and then I'm gonna have a second graph at y equals this number and then find the intersection. Okay, now let's think of a window. I'm gonna say it would be reasonable to approximate, or to give a window for n, which is x in my case, between 0 to like 10 to 15. And because we already know what y value we're interested in, like 20,000 something, I'm just gonna say 2,400, and then a maximum of, sorry, 20,000. 420. 420. Okay, let's graph this. And then this might take a while, but your graphing calculator can do it. There you go. There's my intersection. So now we can calculate the intersection. So it's asking you what are the two graphs, because you can graph more than two at once. But because I have two, you can just press enter twice, and then it asks you to make a guess. So I'm just moving my cursor. And then I'm trying to get the y value kind of close to this. So this is good enough. I'm gonna press guess. So there you go, the intersection is here. And as you can see, the x value is 7. And that is a good sign, because that means you probably did it right, because n has to be in like a natural number. And then is that the question? Yeah, it is. Find the value of n. And then now we move on to section B. And we're making decent time. Oh look, interest question. Okay, we have two friends, A and B. Each set themselves a target of saving $20,000. They each have $9,000 to invest. So Amelia invests in an account 10% or 7% per year, compounded annually. Oof, try to increase your compounding periods. Just a little hint. You'll get a little bit more money that way. Find the value of Amelia's investment after 5 years to the nearest $100. Okay, so we can just use the formula. Future value is the present value times 1 plus the annual interest rate divided by 100, and also the compounding period per year. But because she gets it annually, that's just 1. And then this is going to be to the power of the time, which is 5 years, times the number of compounding periods, which is, again, once a year. So punch this in a calculator, and then we can find out how much money she has. So what is it, 9K? And then plus our bracket 1 plus 0.7 to the power of 5. And then this wants it to the nearest $100. So 1, 2, 6. Not bad. She's made like almost $4,000. Determine the number of years required for her to reach her target. So now we want to find out when she will have $20,000. How many years it's going to take. Okay. So what I'm going to do is I'm going to go to our handy dandy graph. And I'm actually just going to graph the function, which is $9,000 times 1.07 to the power of x, which is the number of years. And then my window, I don't know, I'm gonna say maybe it'll take her 20 years, somewhere between 0 and 20 years. And again, I already know what y values I'm interested in. Because it tells me I want to find out when she's going to hit 20,000. Okay, so that's my window, and then I'm going to have a second graph at 20,000. Graph this. And then there's her money. There's 20,000. This is when she's going to make 20,000. You could also use like logs or whatever. It doesn't really matter. Okay, it's going to take her 11.8 years. I can't believe... Oh, that's... I thought that one question was 5 marks, but it's 5 marks for everything. So 11.8 years. I don't know if they want you to round this up to 12 years. Because it does say how many years it's going to take. It's not going to take 11 years. Let's just say 12. Hey Tofu, how's it going? Alright, and then Bill invests something in account. We don't know what his rate is, but he does get it compounded monthly, so that's better. And then R is going to be set to 2 decimal places. Okay. I don't know why they want this, but we'll just keep this in mind. Because that's the type of thing that I would probably screw up and give you like, I'd give the answer as like 3 decimal places. Oh, hello Oliver as well. How's the new place? It is very messy and a lot of things are unpacked here. Look at all these boxes, and this is just one room. But the place is nice. Okay, find the minimum value of R needed for Bill to reach the target after 10 years. Yeah, it's not bad. We have to buy a couple of things to spruce up the place. Like, apparently none of our closets have anything in them. Like, there's no rod to hang your clothes on. There's no shelves or anything. It's just like a blank space. So today we had to buy like a bunch of closet organization stuff. That was like $1,000. So expensive. Okay, so his function is 9,000. 1 plus R divided by 100 times 12. And then because we know that he's going to invest for 10 years, T is 12, or sorry, 10 times 12. So we're going to do the exact same thing. We're going to graph this, and now my variable will be, my x variable will represent R. And then I find the intersection with 20,000. So let's go back and then change this up. So the exponent should be 120. And then we are going to add, actually, whatever. X divided by, what's 100 times 12? 1200. Okay, just double checking that this looks like the right numbers. Yeah, okay, let's graph this and see what's different. Ah, he gets the money much earlier because the other person's line was over here. Well, we know that he needs to get it much earlier because they told us it's going to be at 10 years. Okay, so again, calculate the intersection. So first curve, second curve, make a guess. So there's his interest rate. So he wants 2 decimal places. Does that count the ones? I don't know. I'm gonna... I'm gonna say, I'm gonna do 3 sig figs. I'm gonna say that this is 2 decimal places. Yeah, I don't care that much to find out the answer to that question. Is this 2 decimals, 8.0, or is 8.01 2 decimals? Because it has 2 decimal places. Yeah, whatever. Hey, okay. So, then they have a third friend, C, who also wants 20,000. He's gonna put his money in a safe, is not gonna earn any interest. His system is to add more money to the safe each year. Each year he will add half the amount added in the previous year. Show that Chris will never reach his target if his initial deposit is 9,000. Okay, so for those that don't realize what's happening here is that Chris is following a geometric series. So let's see. Each year he adds half the amount from the previous year. So next year he adds 4,500. Then the next year he adds 2,250, and so on and so on and so on. So his common ratio, so this doesn't mean interest rate, this is common ratio for a geometric series, is 1/2. Now, we need to show that he will never reach this target if his initial deposit's 9,000. So there's lots of ways to show this. Never to me implies that he could do this forever and he won't get there. So to me, this says that I'm going to find the infinite sum. And the infinite sum, I guarantee it, is going to be less than 20,000. Which means that he could keep doing this forever and he won't get there. So following the initial sum formula, that's the first term, divided by 1 minus the common ratio. So, okay, I guess I'll show my work. 9,000 divided by 1/2 is just 9,000 times 2. So he's only gonna make $18,000. So I guess you'd have to write a sentence. Even if C lived forever, let's make this more entertaining for someone that was marking it. Even if C was an immortal, he would never reach 20K. Because the infinite sum is 18K. Something like this. I'm sure they're gonna give you a mark for a proper explanation of things. Okay, and then find the amount Chris needs to deposit at the beginning so that he reaches his target. So now, in other words, we need to solve this equation. Which is pretty straightforward. You just take 20,000 and then you would divide it by 2. So Chris is at a little disadvantage, even though he is an immortal. He needs to have $10,000 at the beginning. Yeah, this paper is pretty easy so far. Nothing super out of the ordinary, except for that graphing the line of best fit. Oh, and then the binomial expansion question. Okay, let's see. Two straight fences meet at point A. And then there's going to be a field in between them. I'm assuming that this area here is the field. a horse is tied to a post at P. When the rope has a length of r meters. Okay, point D is on one fence and point E is on the other, such that PD is the same as PE, which is also the same as PA. And then those are all obviously R. And then angle DPE, which is right here, is theta. And then all this is shown in the diagram, sure. The length of the arc DE is 28. So I know that this is 28. Okay, write down an expression for R in terms of theta. So we know that the arc length is 28, and we know that arc length is R times theta. So in other words, we want an expression for R, so R is equal to 28 divided by theta. Now we need to show that the area of the field that the horse can reach is this value. Okay. So if you imagine this horse, because he's tied to this rope, he can basically only go in this wedge shape. So that area is fairly easy to calculate. It's the area of the sector plus the area of this triangle. Okay, pretty straightforward. So the sector is 1/2 r squared times theta, I think. It's in your formula book. And then the area of a triangle is 1/2 r squared times sine of this angle in between the two sides that you have. Now, this angle is related to this angle. I didn't draw it properly, but as you can see from the diagram, that right there is the supplement. So together, orange and, well, this has to be pi minus theta because these two together make pi. So this is pi minus theta. Okay. So we add these together. Not bad, looking good so far. We're going to use our thing from part A. We're going to substitute this expression for R in here, because as you can see from the formula, there is no variable R, so everything's in terms of theta. So what is that going to look like? Okay. And I'm sure if we keep simplifying, it'll look like this. So as you can see, this is factored. So we're going to take out a common factor of all of this, which is present in each term. And let's just see. I bet you that 28 squared divided by 2 is going to be 392 right there. Okay, so 392 over theta squared, and then you're going to have theta plus sine pi minus theta. Okay, so you can see we're basically done. There's one little thing. You need to realize that sine of pi minus theta is the same as sine theta. There's lots of ways to show this, but I think this is the easiest way. In quadrant 1, whatever value sine has, the angle here, which is pi minus theta, which is in quadrant 2, these have the same value, no matter what. Because again, sine is measuring the height of a coordinate on the unit circle, so they have the same height, so the sine value is the same. So this is just sine of theta. This is theta. This is 392 over theta squared, and then you're done. Okay. Now, the area of the field that the horse can reach is 460. Now we can find the value of theta. So all of this thing is equal to 460. So you put it all in the graphing calculator, you solve it for when it's 460, and then you're done. Like I said, I'm gonna keep this stream short, and I'm basically gonna end it once I'm done the paper, because as you can see, I gotta unpack stuff still. Or actually, I gotta make a quiz for tomorrow, so I gotta do that first. So I'm gonna solve it on Desmos, just because it is a touch faster for me. So it was 192 divided by x squared, bracket x plus sine of x. And then make sure that I'm in radians. So look at this graph. Whoa. That looks pretty cool. Anyways, and then this is equal to 460, which is all the way up here. So here is my value of theta, 1.44. Cool. Okay. Now, what's next? Hence, find the size of angle DAE. Where the hell is DAE? DAE. They want this angle right here. Okay. So I don't want to scroll back down, so I'm going to redraw it right here. They want you to find this angle. You know R because it's 28 divided by theta, and theta is 1.44. So 28 divided by 1.44, which is 19.4. So this is 19.4, and this is 19.4. And then you also know what this angle is, because this angle is pi minus theta. So pi, I always have trouble finding pi on this graphing calculator. Where the hell is pi? Oh, there it is, okay. So pi minus 1.44, which is 1.7. So, given this setup, what can we do? Or is there a better way to do this than what I'm thinking of? Because this is only 2 marks, and the way I'm thinking of it would be worth more than 2 marks. DAE. I'm gonna do it this way, because just because I don't want it. You see, here's my thought. I was gonna use cosine law, get this one, and then I can use sine law to get this one. But I think I'm going to use the fact that I already know what the area is. Yeah, I think I'm going to use the fact that I already know what the area is. So the area of this triangle... Actually, does that even help me? Because all that would do is tell me this, and then I'm just back to here. Fine, we'll just do it the long way. I can't believe it's 2 marks though. I guarantee there's probably a faster way. Has to be a faster way. There's no way that me doing cosine law and then sine law is 1 mark each. Whatever. Okay. I'm gonna use a cosine law calculator. Okay. So 19.4. 19.4, 19.4. And then that angle is 1.7. 1.701592. Okay, so that opposite side is going to be about 29.2. And then we can use sine law to get this angle. Let's see if Google has a sine law calculator. Okay, I want to solve for an angle in radians. So the opposite side of my triangle is 19.4. This side I just found out was 29.2. And then beta is the other angle, which is 1.7. 1.701592. So that angle is 0.72 radians apparently. If you guys were expecting me to walk you through cosine law, sine law, I'm sorry, but that's something you can easily do once you have these 3 numbers. You can get this one using cosine law, and then you can get this one using sine law. But still, it's only 2 marks, so I don't know what's going on. I feel like there's an easier way. But time marches on. Oh my god, never mind. It marches on to the continuation. So what is this? We make a new fence right here. The poor horse cannot have as much area as before. Actually, maybe he does. Who knows? Point C is due west, so this is horizontal from the orientation of our paper. And then AC is 800. The bearing from B to A is 195. Okay. This has nothing to do with the last question. Alrighty, so the bearing from B to A is 195. So bearings start at north and then they go clockwise. So this is 195. And then find the size of angle ABC. So they want us to find this angle right here. Okay. Now, we already know what this angle is. It's 0.72, apparently. according to this. As long as I did this right. So let's change it back to degrees. So that's 41.2 degrees. Okay, now let's see if we can get some geometry going here. So when working with bearings, it would be good if we could draw north, south, and east and west axes. So if I do it like this, then this little piece right here of blue that's past 180 is 15 degrees. So this angle is 15. I don't know if I need this yet. I'm just writing it down. And then we also know, what color should I do? I'll do red. We also know this angle, and I feel like this one's gonna help me out. Right angle with 15. Oh yeah, you can do that too. Oh nice. I was gonna do it this way. Find this one, and then you can find this one. Then you can find this one. But let's do it Vincent's way. Let's just draw a right angle. So that means that I can find out this angle right here. So 15 plus 90 minus 180. So 75. So that angle 75, which means that this angle is the supplement to it, not the complement. Complement is when they add to 90 degrees. So, oh, this is 105. Okay, there you go. We just found this out. Is 105. Okay, find the length of the new fence required. So they want us to find this length. Okay. Easy enough to do. If you just ignore all of the diagrams and you focus on what's in the triangle, it's another sine law. This is 800. This is 105. This is after you convert it to degrees from earlier, 41.2, and then we want to find the fence, which I guess I'll call x. So put that all into a sine law calculator, and I'm gonna cheat because whatever, you guys can do sine law on your own. Okay, angle alpha is 41.2, nice. Now, the other side is going to be 800, and the angle is 105. So the fence needs to be 546 meters. Sure. I mean, I'm sure this is the process you want to go through. I don't know if these numbers are exactly right. And I'm still, how can you figure out... I wonder how you can figure out this more simply. Oh, okay, never mind. I'm dumb. Let me do that real quick. So we just found out this angle, which is whatever it was, 1.44. Which means that this angle, I didn't draw it right, but this is supposed to be a straight line. This is the supplementary angle. Jeez, I knew it was easier than what I was doing. Yeah, it's an isosceles. Okay, because this is R and then this is R, this is an isosceles triangle, which means that these two angles are the same. So all I do is I just, you know that they all add up to 180 together. So I take this, and then I subtract it from pi, because we're in radians, 180, and then I just divide it by 2. So it should be 0.72. Which, I don't know if that's what I had last time, but... yeah, okay. But that's probably how they wanted you to do it, instead of doing cosine law, sine law. Oh well. And then this is the last question. Okay. Looks like calculus. Looks like some pretty ugly stuff is gonna happen. And then I'm free. And then I gotta make a little quiz for my little grade 8s who are doing integers in order of operations. Why are you disappointed in yourself? Because you didn't do English? Okay, consider this function. The function and the line will intersect at point P. Find the x-coordinate. Okay, so you graph both, you find the intersection. I'm going to Desmos. I've already shown you how you can do this in a TI-84. So let's just expedite the process. Were we that bad in grade 8? No, these are my, you know, mainstream grade 8s. And you have to keep in mind, they haven't been doing math for like almost 2 years now. And you know, with our new school system, it's a little tough. We're taking it slow. Were you better? In ways. In some ways. Okay, so here's the graph. And then here's our intersection. And then the question wants to find the x-coordinate, so it's 5, 5, 6, 6. So 5, 5, 7. Why are you are in grade 11. Why are you comparing yourself, your math ability, to some fresh grade 8? You are beyond this now. Okay, now, some line has a gradient of -1, sure, and is going to be tangent to the graph of f. Black banana, 1, 2, 4, thanks. Tangent to the graph at a point Q. Find the exact coordinates of Q. Sure, okay, so because the gradient is -1, nope, W did not get it. Although I would say that she's close. She's narrowed it down to all the IB art students. Take away Serpent, because she knows who Serpent is. Oh, and then she's gonna ask people, maybe tomorrow, if she remembers. So nobody tell her. Nobody tell her. No, well, all the IB art students from September. Anyways, so what we're going to do is we are going to solve this equation for when it's equal to -1. So you can take the derivative, again, solve it for -1. Did I say 4? Whatever. She's narrowed it down, okay? But I'm not telling her. So, again, I'm using Desmos. If you want to, you take the derivative. It's not that hard to take this derivative. You would just do a chain rule and multiply by -0.5. So the derivative is -45 e to the -0.5x. Actually, here. So -45, oops, -45 e to the power of, well, she wants to know who you are in real life. Okay, so here's the derivative, function of the derivative, and this is equal to -1 at this value right here. So this is the x value, 7.613. So this coordinate lines up with this coordinate. I'm probably not going to be able to drag right onto it, but this actual coordinate on the function itself. But I'm just going to calculate that right now. Seven, 6, 1, 3. Still offended? Don't be so mean. Alright, so let me explain what I did. I found the x value for where the gradient is -1. And then I'm taking that x value and I'm plugging it into the original function because the question wants the coordinates of q. So this is the y coordinate of q. It's at 2, more or less. So q 7.61 and 2. Yeah, it looks like about 2. Okay, and then show that the equation of this line is going to be this. Do they really want it that way? Okay, here. So they notice that they have this natural log business going on. And that's because they solved this equation using logs instead of graphing it. I mean, we could have done that too. I guess that's... I guess. Okay. So we isolate for the exponent, or the power, and then we change to logarithmic form. And solving for x, this is the x value in exact form, and then this is the decimal, the 3 significant figures of this. Anyways, so they want this because we're going to use it to show that the equation of the line is going to be this. But that's fine. We have the point, and then what we do is we put this into point slope form first, point gradient form. So it's y minus 2 is equal to -1 x plus 2 natural log 45. So this is just y minus y1 equals m times x minus x1. Okay, and then all we do is we rearrange it, and then you'll get what you want to get. And I think that's what you wanted to show. Oh, they have a plus here. So I guess I did my logs wrong somewhere. Hold on. Where did my logs go wrong? Because I already know it's going to be positive. So somewhere here I went wrong. Am I going crazy? Is this not the derivative? This has to be the derivative, right? Okay, time to cheat some more. Good old Wolfram. Derive 90e to the power of negative 0.5x for me, please. Okay. Yeah. And then solve this function equaling negative 1 for me. Okay. I mean, I guess. That's the same thing. Why do I have a negative here? Oh shoot. 1 over 45. 1 over 45. One over 45. Okay, so then, because the question wants this as natural log 45, and currently we have natural log 1 over 45, what we're going to do is we just take this little negative, and then we bring it into the log as a negative exponent, which takes the reciprocal, and then there you go, you're done. Yeesh. Stupid mistakes. There you go. Yay. Okay. Now, what happens now? There's a shaded region between the line, y equals x, and then the graph. First, find the coordinate where the line will intersect the graph. So, find this coordinate. This x coordinate. Okay, that's easy enough to do, right? Because we have the equations of both lines. Goodbye. So we have y equals x. So that's our first line. Then we have y equals negative x plus 2 natural log 45 plus 2. So plus 2. Okay, so here is my point of intersection. So 4.81, let's say. You could have also just equated the lines, like make this equal to x, and then solve for x. And then if you do that, you should get natural log 45 plus 1. Okay, then we need to find the area of A. So this one's the doozy. Yeah, and it's worth the most marks. So look at what you have. You have 3 things happening. You have the line y equals x, which is the blue one. You have the tangent line, L, which is in orange. And then you have the function, which is in green. So this is your function. This is L. And then this is, let's call it x, I guess, because it's y equals x. And then we want to find the area of this shape. You have to split this up into 2 sections. And what you're going to do is you're going to integrate y minus x minus the orange line to find the area between these two from this coordinate, which you just found out is right here, to this x coordinate, which you found out way in the beginning. And then you do a second integral to find the area between these 2 curves from this coordinate to this coordinate, which you also found out in previous questions. Okay, so I'm going to cheat and I'm going to use Desmos. So again, we're going to do the integral from the point of intersection of these 2 lines, which I think was this number, 4.81, to the x-coordinate of this point, which is 5.57. And the function that we're integrating is this function minus this function. In other words, it's x minus negative x plus 2 natural log 45 plus 2. dx. And then big brackets around the whole integrand. Okay, so that is this area, 582 or 583. Anyways, I've shown you again how to do this in a graphing calculator in one of the earlier questions today. So yeah. And then I'm going to call this A. A equals this. Okay. Then I'm going to calculate B, which is the second integral. So it's from 557 to this coordinate right here, which is, I think they call it Q, right? Q? Oh, find the exact coordinates of Q. Oops, I didn't read that. That's why they had this answer. this one. I should read questions more carefully. So that's the upper bound of my integration to natural log 45, and then I'm going to integrate f minus L. So in other words, 90 times e to the power of negative 0.5x minus negative x plus 2 natural log 45 plus 2 dx. Okay, so then that's the area of that part. $937. Then obviously the total area is these two added together. So A plus B. Tell me what that is, Desmos. 1.519. So 1.52. Pretty crazy, but they did lay out all of the coordinates for you. So this was more or less each question was kind of building up to this final part. And then am I done? No, there's one more. Okay. Okay. L turns out to be a tangent to both the function and the inverse. So here's the inverse right there. Find the area of this shaded region. So remember, inverses are a reflection across y equals x. And we just found out what this area is in the previous question. So we just multiply it by 2 to get the final area. So 1.52, well, actually, Desmos. Tell me what A plus B is times 2. So 3.04. So this area, 3.04. And then I think that's it, right? I'm done? Yeah. Okay, not bad. Honestly, yeah, I agree. This paper is easier than paper 1. At least for time zone 1. And then, I guess maybe on Thursday, unless I'm super busy, I'll go over HL, oh boy, time zone 1. Unless this kid doesn't ghost me. Look at this. I sent him the scans of the time zone 1, and you know, he's supposed to send me time zone 2. Did I just get ghosted after I sent him what he wanted? I don't know. Somebody go to my Discord. Let me know if you have access to time zone 2 so that I can do this. Mostly because I don't want to do the HL papers. I'd rather go through SL time zone 2 before I start HLs. Alright, so I'm going to end the stream here because like I said, I'm busy and I got to make a quiz and unpack and stuff and build my closet storage solutions because this place came with no closet storage. So yeah, I'm going to call it there. Nice stream. Thanks, Professor Blender Master. Keep wallowing in misery? Look, like I said, you're already late. You might as well take your time, make a quality product, and hand it in on this Friday. You've taken up math to entertain yourself? Damn. You know, Twitch has way more entertaining channels that you could follow. Like people doing art and making music, playing video games, and here you are watching me do math. You're a former engineering student? Okay. You loved math? Yeah. Math is cool sometimes. But thanks for finding me and listening. Yeah, well, you're an engineer, so what happens once you get into life and work? You move away from the actual like mathematics of things, right? And you do the more practical stuff for your job. But anyways, thank you for tuning in. I hope this doesn't make you want to I don't know. I hope it doesn't make you feel bad if you wrote this paper and now it seems very easy in retrospect. I'm reading What is Mathematics? What is mathematics? You tell me, Richard Courant. I wish I could have time to read math books. But here I am, streaming on Twitch, doing math. Okay, I'm calling it here, guys. I'll add it to the list, Professor Blendermaster. Have a good night, everybody. Thanks for watching. See you guys later. Goodbye, goodbye, goodbye.